So if we master everything like in this quiz,
So
like if we fully understand everything, it would be good like for the test.
yes, should be.
Great, thank you.
Yeah. I don't want to say I promise because I feel like I've had people who are like, oh, I knew everything I was doing. And then you have one of those days where you just woke up and it didn't go ideal. But ideally, yes, you should be good. And I would say if you can do this study guide, like this practice quiz, I would look over the printable study guide that I posted. There's a video underneath it. It's from 2 semesters ago. And I don't remember students being super active. It may be kind of long, so fast forward and pause where you need to. But the printable study guide as well is probably a good thing to look over if you're questioning. I would look over it and just see if any of them you don't know how to do. I wouldn't necessarily do every one of them. I'd be like, I don't know how to do that. And then I would try it and then go find your answers. Because there's, if I'm not mistaken, I uploaded a PDF of the answers and then also a video of teaching it too. All right, so I'm going to try to go through some of these I think hopefully are easy. So inverse, so this is x, y, x, y, x, y. Your inverse is just that they flip. So especially when it's a list of coordinates. So the inverse coordinate would be 2, 4, negative 4, 3, negative 7, negative 1, 2, 8, and then in this case 5, 5. Though that 5, 5 is not the same, the x's and y's switch spaces. So it's like to the right 5 first and then up 5, and then this time it's this. I guess it is the same. Still the same. But theoretically, x and y have flipped. For graphs, this is your y equals x. If it reflects perfectly over, then it is an inverse. Another thing, sometimes if you're more of a coordinate person instead of a visual person, so your original, and hopefully on anyone, if you see it on a test on your computer, you're going to have color differences and they're going to let you know. But remember that f of negative 1x is the inverse, and then so f of x is always your original. If they happen to show up the same color, you're looking for f of x. So this is the original. And so that original was a positive 1, 0. And the inverse we know should be 0, 1. And indeed it is 0, 1. And maybe I would test a couple points if there's more than one point that like works. I think mine's pretty gray right now, but that one should be. So 2, 1. Yeah, and then 1, 2, and that does check out. So that is an inverse. F of negative 1 x is the inverse, and the graph proves this because they reflect over the y equals x. That's your correct answer. Y equals 0, just for conversation's sake, would be your y-axis. So that is the y-axis, and it doesn't reflect over that. X equals 0 would be your x-axis. No, I'm lying. I did it totally backwards. Y equals 0 is your x-axis, horizontal line. Your x equals 0 is y-axis, vertical line. Hoy bucks, yes. And if those get confusing for you, because just knowing that I have a lot of math floating in my head, and so do y'all, this is something a 9th grade student taught me a long time ago. It's a middle school somewhere around in this area. Some teacher teaches that. So it's a horizontal line is a 0 slope, y equals equation. So as soon as you saw y equals, then you know that is a horizontal line. So it would have to be the x-axis in this case. So it would go through 0. And then vertical, undefined slope in x equals. Because I know sometimes even for me, and as you just saw, I get the vertical, all that fun stuff mixed up. But if you remember Hoy bucks, it keeps it a little, maybe hopefully a little easier separated. They reflect about the y equals x, and then obviously not, if it reflects perfectly, then that's the part of that answer that's wrong. So the fun part, as we talked about lots of time, where you can use Desmos to kind of get around doing a lot of math. In this case, is f of x the inverse of g of x? So g of x is where they're starting. You can algebraically solve it, or you could graph it, and again, if it reflects over this line perfectly to either side, like an imprint, or if you go to Desmos and find the tables, you could use tables to check it too, like we were doing coordinates, then it is indeed the inverse. I think that's easier. Between these two, thinking like a student, most of us don't like this fraction. So I would take g of x. It looks linear, so in my mind, I'm not super scared to attack that one first. And then I would solve it. So that's where you put your y in the place of f of x first. Then you flip your x and your y. And now we solve for y. So you're going to subtract 18 from both sides. And that's going to give us that x minus 18 equals 4y. 4y is multiplication, so we're going to divide by 4. And that is not going to simplify. So these are not inverses. I'm talking really fast. Is everybody okay so far? Stop me if I run on the one that you're like, oh, that was it. That's the one I don't know. Y equals x squared plus 2. Actually, I put this one in there because I think it was Randall or someone else along the way emailed and asked about the x squared. If it was x to the 4th, x to the 5th, anything like that, you're going to take that number root. So x and y, it would be where we switch them. I mean, where we put them out. So instead of f of x, they went ahead and wrote it in y. So we're going to put our x here, y here. And they just fall into place. So now it's y squared. Now we're trying to get y by itself. So we're going to subtract 2 from both sides, which gives me x minus 2 equals y squared. Inverse of squaring, and I think this is hard for some people to remember because you haven't done it a lot, is square root. If you have a TI 83 or 84 or any of those fun calculators, it is, if you were to hit second and x squared, then it roots it for you. It takes a square root. If you need a fourth root or a third root or anything like that, you're going to hit math, and it should be number 5. And then you can do a fourth root or anything of that nature. But in this case, since you have two variables, you're not really taking anything all the way down. You're just getting y by itself. So x minus 2 is the binomial underneath that equals y, and that's the best you can do. So it's going to be a radical equation that slid to the right 2, if you remember at all, because that minus 2. So it went to the right 2 relative to its parent function.
If there's an exponent on the side of the equal sign, you can just turn it into a square root, right?
If the exponent is a 2. If it was a 3, then it would be a cube root. If it was a 4, then it would be a fourth root. And that's where, but ideally, yes, it is a root. The square part is the only part that makes what you said not 100% correct, but it is a root. So, like, if you needed to, you could use cube root. X root does the 4, 5, 6, 7 indefinite numbers, and you should have that exact same type of formatting on Desmos as well, if you're going the Desmos route. But yes, to undo an exponent, if it's a number, you're rooting that number of times. And just to make sure. So if I have x cubed, we know that's x times x times x. And so when I take the cube root of x cubed, that's asking what did I multiply 3 times? And it's whatever that number on the bottom is, or the letter on the bottom is. So if it was like the cube root of 8 is going to be 2, because 2 times 2 times 2, because 2 times 4 is 2. 2 times 2 is 4, and then 4 times 2 is 8. And so the same thing if it was a fourth root, and I don't know if I'm going to do, I'm going to make this one up. Yep, 16. 2 times 2 times 2. Yeah, 16 is also going to be 2, because 2 times 2 is 4, times 2 is 8, and times 2 is 16. So fourth root, cube root, fifth root, you're still doing the same thing as a square root, but you're doing that number however many times, which shouldn't be a huge deal for this quiz. I don't think I hit you with anything that I can think of right now. Shouldn't be. I usually say cube root or below for quiz stuff. All right. Put it in exponential form. So you're going to grab your base, go out, grab your exponent, come out with your output. So 2 to the 4th power equals 16, which is what we just talked about, because it's 2 times 2 times 2 times 2. So that's in exponential form. Logarithmic form, so you're going to take your base, shove it into the basement. So log base 3 of 9 is, because we're crossing that equal marks, 2. And 3 squared is 9. So same thing. If I was to switch it again, grab your base, grab your exponent, come out with your output, and that's where you started. So a weird L, fun E. What is the exponential form of log 10 equals 1? If there is nothing in the basement, quote unquote, it is an imaginary 10. So imaginary 10, kind of like the 1 in front of your x or any variable. If there's not a number in front of the variable, it is a 1. Here, if there's nothing in the basement for log, it's assumed that it's a log base 10. So in this case, we're going to still take our base number, go grab our exponent, come out with our output. And so that's saying that 10 raised to the 1 power is 10. And that's what logs are saying. What is this base? If it's raised to this, it's going to give me this back out. So if it was for the change of base conversations or just when you were evaluating, so log base, hold on, I don't want to make up a number. That's not going to work. So that, to evaluate it, we are putting in our calculator or in Desmos and just coming out with it. Change of base, you would set it up a little differently. But the question this is asking, oddly enough, a lot of people don't realize that these are actual, like, written, like a conversational question. And this is saying, what did I raise to? What power is 2 raised to equal 32? So if you did 2 times 2 times 2, we got 8, 16, 32. So 1, 2, 3, 4, 5. And the reason you do change of base or have to put it in your calculator is it's not usually a whole number. It's a fractional exponent or a decimal, because obviously all numbers count with decimals or not, especially in our level math. But that's what log base whatever of so-and-so is saying. What is that? Log base of whatever is what? Since I'm using such great math words on that one. True or false, the logarithmic form of, so don't panic, it looks wild. This is going in the basement. So that means we know it's going to be log and we don't need to put anything down there because it's a 10, it's assumed. We're going to make our L, that's 4x minus 1, is x minus 3. So is that correct? So this would be a true statement. It is correct. And the second one, so log base x, so we're switching to the exponential, so we're going to take our base, grab our exponent, come out with our output. So x raised to 2x minus 3 equals 3. And it's probably easier for me to say than for you to actually take this way. But with all those x's and the minuses, that's where people, I think, get confused or get overwhelmed or kind of scared. But if you remember to make that e every time, especially in a log one, it is what it is. No matter how weird it looks, how ugly it looks, if it is a log base of equals a number or even a binomial, you're fine. As long as there's nothing extra on this side, like the log base of is all you can have. And when I mean that, I mean log base of. Those are the only 3 things you can have to put it in exponential form, no matter how strange it looks. All right, so transformations of logarithmic functions. So this is just like our absolute values. So x minus h plus k, and this was in parentheses. So the minus h, we put a positive 2 here to go in that h place. So that means it went to the right 2. And on that practice, it was saying that these would not be written on your, you guys were all there the day I said it when we did our transformation quiz. I don't know what it is and how to get people to understand that. It says, what are all the transformations? That means what changes happened. Our class did better than a lot. Everyone wants to solve it, not what it's asking for. So it's saying, which way did it go? Right, left, up, down. And then up or down, it went up 3, because that's a positive 3 in your K spot. Did it reflect over the x-axis? It did not, because it's still positive in the front. And was there a compression vertically or horizontally? No, because there's nothing, again, not a number in the front. So it's, and I might be making up the wrong letters, but log, say 10 x minus h plus k. And so it still controls all the same thing. Your A is your steepness. If it's a negative or positive in the front, that's when it flips. X minus h is your right, left. K is your up, down. Everybody's good? Oh boy, and I didn't print the other thing I needed. Woo! Hold on one second. All right, so for domain, that's your X values. Looking at a log function, you know that you are going to have an asymptote, and that's what's really going to matter. It is a vertical asymptote for a log function, so as soon as you see the word log, you should think about vertical asymptote, and that's back to that Hoy bucks. So we know that the asymptote is going to be an X equals, and it is always going to be the opposite of whatever your H value is here. So opposite of plus 8. So it should be a negative 8 for that asymptote. So that's the asymptote. So that's that line, and it's vertical. So we know it's going to go somewhere around here at negative 8. And if we drew for my visual people, so this is at negative 8. This is 0, 0. You could also put this into Desmos and see that it's going to hit that spot and stop. And then at that point, it should be going on this side. So it should be negative 8 to positive infinity, because the graph is going to go this way indefinitely. Your range, it'll go up and down, but it will not touch 8, and infinity can't be a box because you can't stand on an infinity. So that's your domain, your X values.
Miss Sigmund,
Yes, ma'am.
is number 10 vertical?
Is number 10, I don't have them numbered. Good question.
The one above the one that we did just now.
Yes, it should have a vertical asymptote as well.
Thank you.
All log functions, like every single log function, no matter what they do it, slide, flip it, turn it, make it steep, less steep, all log functions are vertical. And then exponential are going to be horizontal. And just to make sure we're right, verticals up and down, horizontals left to right, asymptotes. And asymptote, the idea, one of the funny sayings somebody put together was asymptote, you can look but you can't touch, because you're going to see lots of pictures and you're going to think, but it looks like it touches. No. Can't look like it touches. It actually does not touch. And I think we did do one in the calculator where it starts to give you the errors and those numbers don't pop up. That's why. So for exponential, which I think might be the next one, if I'm not mistaken. Yeah, we're getting there. Everybody's okay so far?
Yes.
Awesome. Thank you.
Yeah.
Sweet. So all the transformations are the following exponential function. So that's going to be your base x minus h. So it has to be in parentheses. That's your left, right. And then anything that happens on the outside is your up, down. So in this case, nothing is up there with the x. So it just went down 5. And hopefully I'm saying this assuming you understand that in transformation is all relative to its parent function. So in this case, just 3 to the x power is the parent function for this. That would have moved around. And then the next one.
Wait, is it so it's not left? It
Nope.
doesn't go forward?
Not left or right, because left or right would have to happen right up here. Like there would actually be a set of parentheses up there that would say plus or minus.
And it doesn't go over the x-axis?
It would not flip because it's not a negative. That 3. I mean, it will cross it, like part of the graph will cross it, but it doesn't actually like turn over. Does that make sense? What I mean, like,
yeah.
Okay. And then the 3, making sure I'm looking at something else, make sure I'm not telling you any of the wrong stories. So I've been working on math 1 and 4 all morning. Yep, and that's it. The only one that would cause a slide up and like an actual like increase again would be if there's a number in the front of it. And that would be written like that's how you want to think about it. There would be a parentheses around this. And then for your left, right, there's a parentheses around that. And anything hanging out on the side, just hanging, dangling, if it's in the front by multiplication, it's changing the rate of change. Like I said, how quickly it's going up. And then your K is going, the whole graph is sliding up and down. And domains for exponential. So again, exponential, you're going to have that horizontal asymptote, which means there's a line that goes this way. So it's just stopping it from going either above it or below it, depending on all the fun factors of that. So your domain, so left and right, is going to always be all real numbers. It shouldn't stop going left or right. It's going to continue in that direction forever. Range would change. Like it can't touch that bottom line, that horizontal line. And the horizontal line, so the vertical, that vertical is going to be y equals whatever this value is. So 25. So this is always your horizontal asymptote. Is whatever's hanging out on the end by addition or subtraction. Range for a log function, same idea but opposite. So I'm only putting up a wall vertically. So it's going to go up and down forever. It's just not going to be able to go left and right forever. So your asymptotes are just putting up a wall in the middle of an open house, if that maybe makes sense. So I can't run left and right forever, but I can run up and down if there's no roof or ceiling. So the range for a log function should be all real numbers as well, which could be written that way or that way. One of the things, no, that's not right. I was about to try to make something up for you and it didn't work.
Miss Sigmund, number 13. I got 25 as well, but it marked it wrong.
Okay, I'll go back and look at it. You said it's number 13?
Yeah.
Okay.
I got 25 infinity, and it got wrong. I got it wrong.
Okay, yes, because it's a y, your domain. So y equals 25 is that it put a roof on your house, right? And domain is how far can you run left or right. If you're in a think like huge, we're in a movie like Weird World, where there's just imaginary walls and we're in space, right? And you're bouncing around. If you have a wall on top or on bottom, then that sets up an issue for your range because that's up and down, right? But if you take off left and right, since this is a horizontal asymptote, there's nothing stopping you from going left and right. So the domain is all real numbers. The range would have your 25 in it, and then either go up to positive infinity or down to negative infinity, depending on which side of the line it's on.
All right, I see that.
Does that make sense? Yeah.
Yeah.
So horizontal asymptote is a ceiling or a floor. So that means your range is going to, your range is going to change. Like have parameters. Vertical asymptote is walls on left and right. So then in that case, your domain is going to have like boundaries. And then so vice versa, since you have a roof, you can run left and right forever. If you have walls on the left and right, you can run up and down forever. By forever, I mean infinity or all real numbers, all of those type things. We're boogieing. I hope I'm not talking too fast, guys. Sorry. Solve for x. So again, when there's log base something on both sides, you can just get rid of them. They cancel each other out. And then we're going to solve. So get all your variables to one side and all your whole numbers to the other side. I like to work towards my variable being positive. So I'm going to add 4x to both sides, because negative 3x is larger. So that's going to give me x plus 2 equals a negative 7. I need x by itself, and it's attached with a plus 2. So I'm going to minus 2 minus 2. And x equals a negative 9. And you're done. Everybody okay?
Yeah.
Perfect. Okay, exponential problem. So the problem with this right now, where your red flag would be, is there's an x in the exponent, which means as soon as you see an x in the exponent, you know you have to get it in logarithmic form from this point forward in your math careers. So I need to be able to do base and make my L. This plus 1 is a problem because it's in the way. So we're going to subtract 1 from both sides. So I have 8 to the 3x equals 42. Now I can shove 8 down into the basement. So log base 8. Go grab my of, and then come out with an is. Of 42 is 3x. And I try my calculator. There it is. And you can do log base 8 of 42 as a change of base, which would be your basic log button 42, because it's still upstairs, not in the basement, divided by basic log button, guy in the basement stays in the basement, or denominator for a math term. So it should be 1.79. I'm going to go 7 because otherwise it just all rounds all the way up. Equals 3x. Or your math, I think I'm in the right place. Yep, log base. And then you're going to go in and put an 8 and a 42, and it gives you the same answer. So just for future, because they will say it depending on who you have for math 4 as well, change of base is where you just flip it and make the, and when they say change of base, that's making both of these a log base 10 of 42, log base 10 of 8. So that's why that works. But for most of you, you should have this opportunity for the rest of your life. We actually had that discussion this morning with a bunch of other teachers that I don't know why you have to learn, but just know they both exist. Then at this point, you're going to divide by 3. So if I leave it in my calculator, divide by 3, and I get 0.59, and I'm going to the second 9, because again, it'll round all the way up to tenths. If the instructions say to round to tenths, by all means, go for it. I will tell you, though, with a lot of this math in math 3, and I learned the hard way as well, because math 1, I'm a big pennies fan, so hundreds seem far enough because money seems realistic for real life most things. If you round too far in for math 3, it will completely send you down a rabbit hole without the right number. So as often as you can use a true fraction or a true decimal, do it. The other way you can plug this in your calculator, if you choose to use that's not what I want to do. Choose to use a calculator, and you probably can do the same thing in Desmos. I haven't tried it there. But log base 8 of 42 divided by 3 should give you your perfect answer as well. And I say that because I found out the hard way the first 2 semesters teaching math 3. If y'all's multiple choice answers, like as much as multiple choice should be a gift, is not in the exact format as what you get in your calculator, a large percentage of you guys don't pick the right answer. So as accurate as possible, and then work backwards or the other way around would be my suggestion for EOC questions and test questions in your future math classes. Give yourself as much room to not mess up. And sometimes when we start to round early, it's oopses, but it happens. And then you end up in a mess at the end because unfortunately they all multiply all the way in. And when they're that long, it makes a difference. All right. Solve the following log equation. So your problem is that x is with the log. So I can't just do change of base or type it in log base in the calculator. So I have to get it in the format where it's only log base, then your output, like log base of, and then I can switch it. But right now I have that -2 out here. That's a problem. So we're going to add 2 to both sides. And that's going to get me to log base 6 of x equals a -1. Now I have log base of, and that's good. So I can switch it to exponential form. And you're switching it to exponential form because the x is with the log. So 6 to the -1 equals x. And anything raised to a negative exponent. So another fun fact is, since you now have your calculator back for indefinite until you have a teacher who just wants to torture you, you can type this in your calculator and it will fix it for you. But any negative exponent just shoves it into the basement in the denominator. So if it was down here and it was a negative exponent, you raise the roof. So for my math 1 guys, in class we dance and raise the roof, and drop it like it's hot if we have negative exponents. So, and then anything raised to the 1 is itself. So your answer is 1/6. And again, this question is asking, when I raise 6 to the negative 1 power, what do I get out? Because of the x being where it is. All right, next page. So change of base. So this question says use a change of base, and I did that on purpose just so you remember that word, and hopefully you understand that you can do change of base, which is log base 10 of 40 over log base 10 of 3 and get an answer, or you can use your log base. And in this case, also, it's a little bit of a test. If you don't know change of base, if you solve this, so math, 0, A. So log base 3 of 40 is 3.36 or 3.357 and so on. You can test your answers here. So log 3, well, that's when, log 40, not match. Log 3 divided by log 40, not match. And then log 40 divided by log 3. And I think most of you that I'm talking to right now, live time, you already are probably the kind that know to do that. But if it's a multiple choice question, guys, work smarter, not harder necessarily, and double check, because you can get rid of some, and then you have a better percentage chance. If you can't get rid of all of the bad ones, still better. So it's 3.35. We'll go 8. All right. Oh boy, we're shooting from the hip on this one. All right, Ryan purchases a car. 4. So that's our starting amount. The car appreciates, which means it's going to get more. So that's 1 plus 10% annually. So that's 0.10. After 6 years, what is the car worth? Round to the nearest hundredth. So raise it to the 6th, and we just solve. And it should be worth $23,021. And in this case, you definitely just want to go to pennies because there's no reason to go further because it's money, and money is a logical thing that doesn't go into the abyss of decimals. That one should be very much like a Math 1 problem. So hopefully that feels like a gimme, hopefully. The biggest thing students still mess up is not putting that in as a decimal. So make sure any percentage, even if it was 10.3, it would be 0.103 when you plug it into your equation. No matter what, it has to change. If it has a percent symbol beside it or the word percent beside it, change it to a decimal. And to change it to a decimal, you can move the decimal to the left 2 times or multiply it by 100. Divide by 100. Divide. Yeah, divide. You good?
Yeah.
Thank you. Okay, so 1996, that is absolutely irrelevant. There are 85 squirrels, so 85 squirrels is where we're starting at Reservoir Park. The population increases by 12%. So before I even start doing anything, I would do this. Each year, how many years would it take for 425 squirrels in the reservoir? So that's when we're done. So relative to our last one, that's our output. So we know we should have 85 squirrels. The population is increasing, so it's 1 plus 0.12. It says how many years, so that's how long. This is your time, equals 425. So this is the correct setup. Only one of these is the correct setup. So it should be this one. To solve this, like if it happened to be one that you needed to solve just because we're here and we're talking about it, you're going to want to divide by 85 because this is our base. That's extra. This is exponential, and we're going to try to switch it to log. So divide by 85. This is where I was talking about. Be careful taking your decimals because it will really, really, really mess things up. And that decimal is not a decimal, so we can just use a 5. So that's 5. So 1.12. Most of them, to be fair, are decimals, so I highly recommend using the fraction with parentheses for accuracy again. If you run into these where you have to switch them, use the fraction if it's not a whole number. So then I'm going to change it to log base 112. 1.12, sorry, of 5 is t, and then you could solve it, which should be 14.2, which is over 14 years. All right, future amounts of $90, that's our A still, invested for 2 years at 20% compounded weekly. So then our R is 20%, 0.20, divided by weekly, so 52, for 2 years, times 52. And in the formula, I believe these were N's. This is a T in our notes that we used, and this is your R, and that is your starting value. And I think they use a P normally or an A, depending on which one you watched. And then you're just going to plug it in to your calculator at that point. Two times 52 is 104, so I'm just going to use 104. And fingers crossed. There we go.
Miss Sigmund,
Yes, ma'am.
I have a question. What
Yes.
does the delta math do?
The delta math as assigned today?
Yeah.
It's not. All of that is review. It's just your choice to what you want to study.
Oh.
Yep. It's just study stuff. And that's why it's so big. I type beside it, if you don't want to do the whole thing, don't worry about it. Like if you know you're nailing whatever, inverse functions, and you don't need to practice it, then you don't have to do it. It's not extra credit this time. It's just more like, here's a bunch of things, see what you want to do. I know I got a lot of feedback in our surveys that you preferred quizzes and such, but I didn't want to go straight that way because then you get no feedback. And if you're messing up, that's not the way you want to mess up right before the quiz necessarily. So everything that's assigned today is just study for yourself.
Thank you.
I'm pretty sure I'm not telling you a story. Yes. If when we're done with this, I'll go double check. But I'm almost positive everything I posted today was do as you need. All right, last page. Oh, no, it's not the last page. There's one more page. That has basically a bunch more review stuff, though. 2 of the last questions were review from previous. Yeah. Okay. So 5,000 is compounded quarterly, so we know we start with 5,000. Compounded quarterly. What is the profit interest received at the end of the year? So compounded quarterly means we're going to gain. Right? Am I doing this right? Yep. This is going to be 0.055. Move it to the left. For 12 years, which is going to be our time out here. It's quarterly, so that's 4 times every year. This question, the reason this one was here is because I did not see this on another person's EOC along the way. The profit is not the final answer. So when you do this math, that answer would be what's in the account now, but that's not your profit because you started with 5,000. The profit would be whatever you made above 5,000. So that's why that question's on here, is hopefully we can catch that verbiage difference, that it's not how much money is in the account, it's what did they earn on top of their normal, what they put in there. 48. So the output, what's in their account now, is this. And then so the profit is the difference of those. Which should be 4, 6, 30. Nope, that's not right. Let me try and be lazy. Yeah, it is. And 56 cents. Cool. So this is the profit. Both of these answers on an EOC will be absolutely there if it happens to be a multiple choice question, because they know that you're going to get excited. You just solved it correctly. You got an answer. You're going to jump and run. So be careful. I can't say it enough. Read the question, do the math, get an answer, read the question again. Highlight, especially if you have something to write down. If you can highlight on your computer. Make sure you're answering the question that is asked. So this one is just going back. So logarithm is going to have a vertical asymptote, which again is your Hoy-Bucks. So we know that's going to be vertical. It's going to be an x equals, and it's x equals the opposite of h. So it is x equals your h value. Depending on what notes you see, they say opposite of h. But I think from our transformation lessons and the way that I teach you, if you remember, it's your true value h. Not the h like if it was a negative, like x minus 3. They say opposite of h because they know that you're going to say that's a negative 3, so it's a positive 3. But it's the actual value of h that got plugged into the equation. And like as far as deciding this went right or left, I think more this way. So it's x equals h. So for your exponential, that is your horizontal asymptote. That's horizontal, vertical. So we know it's going to be a y equals. And y equals is your k value. Whatever the k value is. Logarithmics have horizontal or vertical. They have vertical. And then exponentials have horizontal. Last but not least, we're down to our last three. What is the domain for the function graph? So this is what I was talking about. Like this is your asymptote. So we put up a brick wall, not a ceiling or a floor, a wall. So that means from here, all the values to the right. So this is to our positive infinity. So greater than. X is greater than if we're moving to the right. It cannot actually touch that asymptote. So you don't want the equal to. So it's x is greater than 2. Everything to the right of it this way. All real numbers would be probably what I would call your dummy answer, and not calling anybody a dummy, just the one where you're like, oh man, what the? And then that would be it, because your all real numbers would be your range. Because you can go up and down forever because there's not a ceiling or a floor. I put this one on here again from our last quiz because I know we had a conversation about the answers being duplicated. When I went back and looked at it, the duplicate answer I don't think was the correct answer. So I wanted to make sure we look at it one more time together. And then so you went back and looked and all the things, because the more you experience these, the better you're going to get at them, as ugly as they may be. So we know we have a quadratic, a linear, and then our radical. So all three of those are quadratic, linear, and radical. Your quadratic is definitely a solid circle at -5, open circle at 0. So, and that's just me working through the things that I would start with. I would start with a quadratic, which might be really backwards. My brain has definitely been known to do that. But I know it needs to be a solid circle. So that means this one is out because that's not a solid circle. So we're down to these two. And then my 0 was an open circle, so we're good there. If I look at my linear, both of those parameters are the same, and both of these parameters are the same. So now you're actually looking at transformations of your parent function. So this quadratic, it is negative. That's awesome. But there's not a difference between these two. So I wouldn't get too far into the left 2 up 6, because left 2 up 6 is accurate for both of them. Because remember, that's your vertex, HK, HK. Your linear one, they're exactly alike. So the only one that's different is your radical function here. And this means it went down 1. And this means it went to the right 1. And that's relative to its parent function, which should start at 0, 0. And in this case, it did go down 1. So this should be your correct answer. Is everybody okay with that? I know it's a throwback. Perfect. Thank you. And then last but not least, I put this one on there again because this is what the ESG released for piecewise solving. So I want you to practice, 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 see it enough until you're like, oh my God, it's still there again. That's what's happening right now. So h of -4 is deciding which one does -4 fall into. It does fall into the equals. So we're going to do -1/2 times the -4 minus 15. Negative times a negative gives me a positive 2. Minus 15 gives me a negative 13. So this is a negative 13. Bring down my plus. I'm going to multiply h of -2 by 3. So we'll figure out what h of -2 is. So you have to decide, is -2 less than -4 or greater than -4? Because hopefully we know it's not equal to. It is greater than -4 because it is moving to the right on the number line. So then we're going to take 20 minus 3 times the -2 squared. Be very careful. I cannot say this enough either. You guys are going to hear me say it 100 times because you're the only ones that really show up. To use parentheses around a negative when you raise it to the second power. Because if I ask you what a -2 times a -2 is, most of you have no problem telling me +4 because a negative times a negative is a +4. If you do not put parentheses, your calculator will tell you -4. And you will believe it because that's what we do. So be careful. It's going to be a +4. 3 times +4, so I have 20 minus 12 should give me 8. And that 8 goes in here. -13 plus 24 gives me a +11. So the actual answer to the question is +11.